Hello, everyone. Welcome to today's webinar, Real-Time Machine Learning in SingleStore with MindsDB. My name is Diogo, and I'll be your moderator. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you are currently in a listen-only mode. You may submit questions throughout the session using the Q&A function in the lower right corner of your console. We will answer everyone's questions after the presentation. After today's webinar, you will receive an email with a recording. If you wish to contact us, please email us at team@singlestore.com. So let me introduce our speakers today. Jorge Torres is the co-founder and CEO of MindsDB and visiting scholar at UC Berkeley. Prior to founding MindsDB, he worked for a number of data-intensive startups. Most recently working with Anish Chopra, the first CTO in the US government, building data systems that analyze billions of patients' records that led to savings for millions of patients. We also have Oliver Schabenberger. He's the Chief Innovation Officer at SingleStore. He's a former academician and a seasoned technology executive with more than 25 years of global experience in data management, advanced analytics, and AI. Oliver was previously COO and CTO at SAS, leading software innovation, and Oliver holds a Master of Science and PhD degrees from Virginia Polytechnic. We also have Carl Sveer. He's the Senior Director of Engineering at SingleStore. He joined the company in 2013 to help figure out how to build the world's fast database company. During his tenure, Carl has worked on everything from SingleStore Studio to the database engine and considers himself a software generalist through and through. Welcome, everyone. Oliver, you now have the floor.
Thank you, Diogo. I'm going to give you a little introduction into data-intensive applications to start off the webinar, and then we'll find out about how to build applications, what makes data applications data-intensive, and how machine learning, SQL-based machine learning at the data layer plays in. We'll also have a beautiful demo on how this works in practice, and we'll spend about 45 minutes on this and have about 15 minutes for Q&A. So let's get started. What are data-intensive applications? Is your application data-intensive? It probably is, because the data intensity of most applications is increasing these days. So what do we mean by that? An application is data-intensive when the data itself, not the compute, storage, or networking, defines the constraints of the application. Now, this can manifest itself in many ways. Maybe your data are growing in volume or velocity. Maybe you need to process 5 times as many queries today than you needed to do 6 months ago. Maybe your app needs to handle more diverse data types, documents, unstructured data, video, images, audio. Or maybe you need to add search capabilities or geo-referencing, or the number of concurrent users suddenly increases by 10x. Data intensity is actually a good thing. We want that. But when data intensity leads to complexity, then it turns into a problem. So when you have to stitch together 3 or 4 databases just to make your app work, that adds complexity. Or when you want to have a real-time response, but you have to forego that because your data layer cannot handle fast ingest, then you give into intensity instead of handling it. Now, SingleStore is the database for data-intensive applications. A general purpose database that is really multi-model. Transactional workloads and analytical workloads with extreme performance, check. Geospatial analytics search, check. Hybrid multi-cloud, check. Fast ingest, real-time response, check. You get the idea. We believe that SingleStore is the perfect platform for modern data-intensive apps, helping you to drive out complexity while handling the increasing data intensity. Now, for most of us, the data are not the end goal, right? It's what we do with the data, the insight we get from it, decisions we can make with the data. That's really what matters. But this also drives up the data intensity of applications, because those decisions have to meet SLAs. You might have to respond to a request in real time. A query might have to return results in under 10 milliseconds. And those decisions, they need to support something. They need to support the business. They need to support the organization. And all of a sudden, you need to forecast, predict, classify, make recommendations. You need to discover relationships in the data. It's not just about storing the data. It's doing machine learning with it. This leads us to machine learning, another important way in which data intensity increases, and the topic of today's webinar. As a developer of apps, a web developer, as a data engineer, or a database admin, you want to enrich what you can do with data. And by my definition, many of us are probably citizen data scientists. There's someone who desires to do data science, get the goodness of machine learning, but you're not formally schooled in the ins and outs of the discipline. How to choose between gradient boosting or support vector machines, a concurrent neural network or a recurrent network, logistic regression or random forest, how do you choose? But you know what enterprise data are important, and you need to take those data from storage to decision using machine learning. So how do we bridge that gap? How do we enable you to use machine learning? One way is by bringing it closer to you and closer to the tool set familiar to you. That means bringing it to the database and to SQL. And that's the context for the partnership between SingleStore and MindsDB. So how does this work? How are we bringing machine learning to the database? So to take us through the details and dive deeper into how it works and deeper into the technology, with me are Carl Severe, Senior Director of Engineering at SingleStore, and Jorge Torres, co-founder and CEO of MindsDB. Carl, let's start with you. I mentioned data-intensive applications. How are these applications architected today? What do they look like when SingleStore is in the picture, when they are built on top of SingleStore? And how do things change when machine learning and AI enter the picture? Over to you, Carl.
Awesome. Thanks, Oliver. So today we're just going to be, as Oliver said, we're going to be talking about data-intensive applications, and we're going to be obviously talking about data science. I'm really excited to see MindsDB presentation in a couple minutes about how MindsDB works really well with SingleStore. But before we get to that, let's talk about what data-intensive applications are and how complex they've gotten over the years. Just as an experiment, I sort of threw down a diagram here of what I see as a common data-intensive application architecture. You know, if you look through this diagram, you might see parts of your own stack. You know, you obviously might have some type of like front-end service. On the right side, we have things like business analytics, dashboards. You have maybe an application backend that acts as sort of the nexus of your architecture. Many stacks have background jobs running, you know, various types of asynchronous behavior, or even some type of like large-scale analytical compute. And if you see all the arrows in this type of architecture, it's pretty complicated. You know, there's a lot of data moving around, and each time we move data between one place and another, there is performance loss, duplicity, you know, keeping things up to date. Many of you have probably heard the adage that distributed systems are basically the worst idea ever. You don't want to build them. They're really, really hard. Well, it turns out that in our experience, we've actually built crazy distributed applications, and we haven't really built them the way that like a modern sort of theoretically correct distributed application should be built. Instead, we end up with these sort of spider architectures of systems. And so one of the sort of visions of SingleStore, next slide, is to bring together all of these sort of different components into a real distributed system. You know, at the end of the day, you need data storage that can handle many different modalities of data, whether it be you know, your high-speed transactional processing, your OLTP workload that's powering your application backend, whether it be more like a big data workload that's running like large-scale analytics on historical data as well as real-time data. You have all these different workloads, and SingleStore has been always focused on bringing all those workloads together into one piece of technology. And that's why we're called SingleStore. You know, that's really our focus. So let me talk a little bit about SingleStore. What I like to say is that SingleStore makes data-intensive apps easy. So a data-intensive app really is a backend, so your nexus or your sort of like brain of your system, a front end, some type of view to whoever is gaining value from your system, and then usually a lot of dashboards. In a modern world, we're so focused on data that we need to be able to visualize that data. And so most applications have many dashboards, whether they're more focused on business or on metrics, on users, or on behavior. And so SingleStore has been all about powering native-intensive apps, and we do it using a couple of key features that I want to point out. The first key feature is universal storage. SingleStore Universal Storage is a tiered storage solution, which automatically makes sure that your workload is super fast when it needs to have super low latency transactions. But it can also scale to that sort of big data analytics that you might want. And then at the same time, we will sort of naturally flush data out to data lakes whenever it's historical and maybe you aren't querying it that frequently. So this can help sort of blend your cost model and make sure that SingleStore can scale for all of your data. We also have, as I said before, like OLTP and OLAP sort of backends. So OLTP stands for Online Transactional Processing. OLAP stands for Online Analytical Processing. And well, sorry. Yeah, anyways, the point is that's how I think about it. And these two types of workloads, they need different storage engines. They usually need different data structures to be optimal. SingleStore has been all about bringing those two workloads onto a single data structure, and that's what we call universal storage. It powers both of those workloads at the same time. And then we also have streaming analytics with our pipeline solution, which allows you to handle Kafka streams natively inside the engine. And then we are compatible with MySQL, which helps make sure that it works inside your workload. So that's really what we're focused on with SingleStore. And the most important thing here is in the last slide, we saw how much this becomes a distributed systems problem. SingleStore is itself a distributed system. So you see this arrow off to the side, scales with your app. Well, as your technology gets bigger, we will scale with you. And that's a simplification. That's a massive simplification. Instead of needing to add a bunch of more boxes on that diagram, you just need to make SingleStore bigger. And we'll handle more of your workload. And that's honestly why I've been working here for more than 8 years. And I think that that's the coolest part of our technology. So yeah, so that's what SingleStore is. Let's move on to sort of what happens when you have a data-intensive app. So as you have a data-intensive app and your app starts being constrained more and more by data, you naturally need to start learning from that data in more sophisticated ways. And that's hard. There's no question. You can go and hire like 1,000 people to go and try to look through that data and understand it. But more and more, the industry is moving towards machine learning and AI to help with that. But machine learning and AI is hard to deploy. Usually you're going to have your massive graph of app architecture, and then off on the side, you're going to have maybe a data warehouse where you're going to periodically flush out a bunch of data and then read it into like a Spark solution to train a model. And then you're going to deploy it to some like serverless platform, like API. You're going to have to keep all that in sync. And you're going to be moving a huge amount of data around at any one point. And that's hard, it's slow, it's awkward. It's just not a great experience. Any of you who've done that, I think would agree that it's pretty complicated. You can definitely build really cool technology with that, but it's hard. So what we're really excited to announce today and talk about is how we work with MindsDB to make ML and AI a little bit more of a natural fit in the data-intensive app architecture. And we thought that the best place for this type of architecture is essentially in between SingleStore and your data-intensive app. And MindsDB satisfies that perfectly. MindsDB is MySQL compatible. So your application is already using SingleStore with the MySQL connection. On this left arrow here, your app is connecting directly to SingleStore to do all of your workload, your transactions, your analytics, and so on. And at the same time, you can easily just switch your connection over to MindsDB, see exactly the same data that you see inside SingleStore through MindsDB, but then have it enriched by training models and analytics that are trained on the fly by MindsDB with your assistance or completely without assistance. And that's really, really exciting. I think that this is a revolution to the data-intensive app world. It allows us all to be focused more on the solution we're providing to our customers, the business objectives, and less on the sprawl of technology craziness that is going on in the data-intensive app world. So yeah, hopefully that was a good sort of very fast overview of what SingleStore is all about. I'm going to pass it over to Jorge, who's going to talk about MindsDB, give a demo, and then we'll have lots of time for questions at the end.
Okay, fantastic. So the challenge, as Carl was saying, is the way that most people do machine learning today tends to treat machine learning at the application kind of layer or the application stack, and that comes with like all the complexities that that Carl was describing. And if you were to think of MindsDB in a way that is similar to how you do other data applications, perhaps think of it as a view within the database, or start seeing machine learning models as views in the database. This abstraction essentially allows everyone to treat machine learning similar to how they treat data. And to walk into that, let me actually walk you into some intuitions. Imagine that you have a very simple table. You have income and debt. And just to double make sure, are you guys seeing the slides with income and debt? Hello?
Yep.
Yes, we're seeing the DB tables tomorrow.
Okay, so to jump into what MindsDB tries to do to make this abstraction, we're going to go for this very simple example. Of course, most data in a database doesn't look like this, but imagine that you have income and debt and you want to query something in this database. Now, if you hit an exact row or an index that points to an exact row, you get a response. But if you query, say, for instance, for income equals to 9,000, then even though this query, it's hitting information that may be very close to one of the data points that you have, you're going to get nothing in return. Now, anyone that has done machine learning understands that you can build a model that fits these data points. And ideally, the abstraction that we wanted to make was, how can we make it so that someone can create that model in a syntax that is very similar to the syntax of creating a view? So imagine that you could say, well, I would like to create a predictor. I would like to name this predictor, let's say, debt model. And I would want to train this predictor from the information that is in this table, in this case, income table. You can do it from also a query or another view. But in reality, you're telling it, well, to create that line, I would like to understand how to fit that line to some data that exists in the table. And of the data that exists in that table, I would like to predict a given column. It can be one column, multiple columns. In this case, you would like to predict debt, and that allows MindsDB to start figuring out how to position that hyperplane. Now, MindsDB, of course, can give you all the flexibility to define how you want that model to be, but you can also let MindsDB to figure out on its own. So even if you don't know anything about machine learning, you can start thinking of machine learning models in a similar concept to how you think of views. And if you know about machine learning and you're dangerous enough to do that, then you can certainly dive as deep as you want into the model building process, all within the SQL syntax. Now, the cool thing about this is that as soon as that is done, then you can now query that line or that surface the same way that you query a table. So whatever you have in the where statement is the input for the model, and now you can get, an estimate of what in this case, the debt will be for an income of whatever, 90,120. And that actually can, be extended to data that is much more complicated than just a simple table, which is the common use case on databases. Let's go back to the simplification that MindsDB then makes is such that, as Carl was explaining it, you can think of data and predicted data the same way that you do it with like your traditional data, and you can keep the application stack as clean as possible. And you can start seeing with MindsDB the machine learning models the same way that ideally most people that really understand machine learning want you to see them, which is another representation of your data. And therefore, they're so tightly coupled that there's no reason for you to decouple them at the application stack. Now, in the rest of the talk, we'll walk you through cloud.mindsdb.com plus SingleStore. We are happy to announce that now you can install, if you want, MindsDB on premise, but to make it simple for everyone, we've made it so that you can also do it on the cloud. It's fully compatible with SingleStore. Again, as Carl was explaining, MindsDB and SingleStore are kind of like MySQL plug and play. So all your clients will continue to play the same way that you are currently doing with SingleStore. So please go ahead and create an account or install MindsDB. We have Docker containers, and we make it easy for you to install on every operating system. But if you want to go straight at it, then just create an account and we'll instantiate a cluster for you. Now, MindsDB and SingleStore have a roadmap of integrations such that we start leveraging on all the capabilities of SingleStore, and it will continue to get better. But as it is right now, we provide you off-the-shelf, very powerful capabilities for forecasting on your data that exists in SingleStore. So you go to SingleStore, get the the credentials and the path for authenticating to the SingleStore server. You put this into the MindsDB cloud, and essentially, once you have that, you can start running queries from MindsDB into SingleStore. Now, the idea here is you can do this straight from the dashboard, or you can do it from a MySQL client. I'm going to describe to you, a few steps that you can do straight from the dashboard, but the same thing you can do connecting to MindsDB straight from the cloud, from the MySQL client, which we'll see at the end. So here we're going to create like a view of one of the problems that we want to solve. In this case is the New York taxi data set, which is a very popular big data set for doing machine learning. And in this particular case, people want to predict what is the trip duration. So how long does it take for a trip given some conditions? And the cool thing about this is that it allows you to, if you play with this data set, which we'll provide for you links, this data set has some capabilities or some requirements that are common to most problems in databases. In a traditional database, being transactional, you have the information that you need for a specific prediction, not just in one single row, but actually you have it in a history of rows. This, in machine learning terms, is what is called time series problems. Now, databases are full of time series problems, and MindsDB has specialized on solving these problems for you. These problems tend to be really hard for you to solve even if you know how to do machine learning, because the constraints of the data that you have in the database makes it so that you're not taking into account just one single column. Many of these problems require you to have information from other columns. In this case, like the passenger count and other information that you want to take into account to make this prediction. MindsDB specializes in this that is known multivariate time series problems. And again, those will be probably most of the problems that you will have to deal with on machine learning when you're dealing with your data, and MindsDB makes this abstraction so you can do it very easily. Let's see how this looks like. Well, the first thing that you tell MindsDB is, you would like to train a model, and you would like to, in this case, predict the trip duration. You can tell it that this is going to be a time series model, and you want to tell it what is the columns that you're going to order by, as well as what are the columns that you're going to group by. In this case, it is a good moment for us to introduce one of the concepts that also make machine learning very difficult in the data. Imagine that in this data set, you have multiple vendor IDs. So you would like to actually partition your data by vendor ID. And what this means is that in a single table, you're actually having many, many different time series problems that are independent from the other. And they're partitioned by vendor ID in this particular case. MindsDB allows you to build one single model that can generalize based on some context of that specific vendor, so that you don't have to deploy different models for one single problem, which in this case is being able to forecast the duration of the trip. As soon as you do this, then MindsDB starts training the model, and you can actually access this model straight from a MySQL terminal. So you can connect to MindsDB, again, from any of your MySQL clients, the same way that you connect to SingleStore is MySQL Wire Protocol compatible. So you go to cloud, mysql.mindsdb.com, same port, and then you authenticate with your passwords on MindsDB Cloud. And it will show you a few databases that we have. Of course, it will show you databases that you've connected to MindsDB, and whatever queries you pass to MindsDB, they're just going to be forwarded to, in this case, SingleStore. But it has a specific database called MindsDB, and this database contains the models that you actually have trained. The interesting thing that you can do with MindsDB is that you can join these models with information that exists in, say, a SingleStore database. So in the particular case of our problem, where we want to forecast what would be the pickup date for, or like the pickup duration for a specific write, then all you have to do is to join your specific model with the data that you have, and then you pass whatever constraints you want to do. Then MindsDB allows you to make this forecast. We introduce a new concept called latest, and that essentially is a way that you can specify you would like to make a forecast into the future as to how this looks like. And you can do this when you train the model. You can actually tell MindsDB you would like this model to make forecasting for like the next iteration of time, the next 2 iterations or 3 iterations. So depending how you train this model, when you tell it to predict greater than latest, MindsDB will try to make this forecast for like the future time sets. Anyway, the main takeaway here is that MindsDB allows you to do exactly this. The ability to create a model in a very simple syntax, and the ability to query a model the same way that you query views, and also to interact with these models the same way that you interact with view data, which allows you to then join this information with other information that you may have. And you're not thinking of deploying machine learning models the way that you do it in a traditional machine learning MLOps cycle. You're thinking of creating these models the same way that you create a table. As soon as you create a table into a database, the table is already in production. And the same thing happens with a model that you create in MindsDB. As soon as you tell it, well, I would like to create a predictor, that is already available for you to consume immediately from your clients. Now, this opens the door for many, many opportunities for, as Oliver was mentioning, citizen data scientists, those people that have the important piece of the puzzle, which is the data preparation site ready. You know, they already have their data in a database, and they have a specific forecasting question that they need to solve. And if they have access to the database and they can plug MindsDB to it, then they can do it with a syntax that is as close as possible to the SQL syntax that they're kind of like already, or all of you that are already used to doing SQL on your day-to-day job, then now you can start doing machine learning at the simplest way possible, as well as without having to deal with all the MLOps that implies. Anyway, we're going to jump into the Q&A, but please feel free to reach out to us directly at community.mindsdb.com. There we have all the resources that you may need to get this started, and we'll look forward to, you know, make you part of our community, ensure that everything that you're doing with SingleStore can have and can be enabled with also machine learning capabilities, and we're looking forward to understand what type of problems you would like to solve.
Thank you, Jorge. So we're going to start the Q&A section. We already have one question here. Please feel free to send your questions using the Q&A panel on the lower right corner of your console. The first question is, can scaling SingleStore be something that should be planned beforehand, or can be done with time, even with data coming in?
I can take that one. So scaling SingleStore can be done online. All of our main scaling operations, like adding nodes and rebalancing partitions around the cluster, moving data, are online operations. So yeah, absolutely, you can scale up while your workload is running.
Awesome, thank you, Carl. The second question is, I am developing apps on SingleStore and want to add machine learning. How do I get started? Where can I read docs and see examples of how to use MindsDB with SingleStore?
Yeah, so let's tackle the last part, which is the examples as well as how to do it with SingleStore. The best point for you to start is to, of course, create an account on cloud.mindsdb.com. The graphic user interface is, it gives you like a guided tour on how to get started. But beyond that, we have all the documentation as to how you can do it with SingleStore through our community portal. So There's docs at MindsDB.com, and the best way for us to really answer all of your questions is for you to join our community. We have a Slack channel that you can join, and it's all there in community.mindsdb.com. But it gives you essentially a workflow that allows you to ask questions as you try to solve your problem, and that reinforced with the fact that you find the information that you need at docs@mindsdb.com. So again, to summarize it, go to cloud.mindsdb.com, create an account. The second thing is join our community. We'll invite you to Slack so you can ask questions proactively there, and we can actually really help you, get the most value out of the integration. And lastly, don't forget that there's always docs@mindsdb.com.
Yep, and similarly on the SingleStore side, we have docs.singlestore.com, and we also have our forums, which I believe is at singlestore.com/forums. So yeah, similar story there. We're really happy to work with MindsDB and can work through issues on both sides.
Next question is, how do you choose the machine learning algorithm? How much do I need to know about different machine learning techniques?
Yeah, that is a great question. So MindsDB starts with an approach which is AutoML. If you only care about the data that you're feeding into the model, then, which is, by the way, the most important part, and that's the reason why we're doing this with SingleStore, the important ingredient to machine learning is data. So if data is your main focus, then you don't have to think too much about how the model is being built. You can visualize the building blocks that this model generation process has followed. But if you know about machine learning and you want to kind of like tweak those knots, then MindsDB provides a capability for you to adjust from a plenty or kind of like a large set of options. So MindsDB breaks the problem on data types. Since most of the data that you can fit into machine learning problems from SingleStore is tabular, then it tries to understand what are the data types that each of the columns has, and it tries to come up with the best way to get a vector representation of these columns. So MindsDB right now supports text, numbers, dates, and from there it brings probably the best way to bring a vector representation of this, which you can specify. Say for instance, for text, if you want to get an embedding, right now MindsDB by default uses transformers, which is probably the state of the art for doing that, but you can also use RNNs or bag of words and things like that. The second thing that MindsDB does is, how do you mix all of that information so you can get to the target variable that you want to predict? And in that, you can pick from a handful of machine learning algorithms. You can start with, like, MindsDB by default tries a handful of those, and then it will pick up the best performing one. But the options that you have go all the way from, simple regression algorithms all the way to, again, using transformers for like time series and things like that. So you have a full catalog of options on which you can choose from. MindsDB will try to pick the best for you, and in some cases, it will try a few of those in parallel and then pick the one that performs the best at the end. So the outcome of this is that you can start even with letting MindsDB figure out something on its own, and then you can open up what the model was generated and you can tweak it. Or if you really want to go from scratch, then we provide you with all the documentation for you to do this.
Awesome. Next question is, can a model call another model? For example, a prediction from a customer churn model could be an input to a model that recommends a next-based action?
That's a beautiful question. So the interesting part about seeing machine learning models as views is that then you can have the same construct as views. So you can have a view, and then on top of a view, you can create another view that depends on the previous one. So the same thing applies to machine learning models as tables. So you can join these models with data that you have and create a view on top of that. And then you can also join that with some other information. So the way for you to chain it is similar to the way similar how you chain tables or views after the preparation steps that you follow one after the other. And that capability essentially is what we want to ensure that you guys test out and give us as much feedback as possible. We are flexible on the syntax, but we try to simplify the syntax such that even if you're dealing with very complex problems such as time series, these problems tend to be easy to solve in very simple SQL statements. And then so that you can chain them together with the same simplicity and capabilities that the SingleStore SQL language provides for you.
Awesome. We have another question here is, do you support models that handle large texts, like multiple phone call transcriptions from a sales interaction and its metadata?
That again is a great question. So we support small text that's anything from 10 words to 250 words, and then we support bigger text. However, like bigger text being more than 250 words, all the way to like thousands of those. The bigger your text is, the slower your models are going to be, and the bigger your computing capabilities have to be as well. Again, MindsDB tries to optimize at its best how you can handle that. But our advice here is to join the community, and then we can advise you into what are the optimizations that MindsDB can make for you to deal with this type of data. But yes, the short answer is we support text, and we have quite sophisticated algorithms for building embeddings from text as well. So you don't have to build it from scratch.
Next question is, we hear a lot about responsible AI and bias in AI. How does the integration between SingleStore and MindsDB help with that?
Yeah, that's the holy grail of machine learning. And what we understood in the process of making these integrations is that MindsDB cannot be the one making the decision as to where there is bias or where is there an outlier that you should care about, or like this type of inconsistency into your data. The best thing that MindsDB can do is to tell you and warn you about data quality issues that it may find before it starts training your model. So if you go to the MindsDB cloud or the MindsDB graphical user interface and you create a view, you can analyze this view and it will give you this information. It will essentially analyze your data set for potential biases and outliers. And then it's up to you to decide whether those are important or not. One particular case, imagine you're forecasting the outcome of a given medication. And if one of the columns that you have is gender, and if MindsDB warns you that, let's say, there's a potential bias towards certain gender on this particular case, it may be wrong. I mean, what I mean is maybe your data is biased towards that and you should take care of it, but maybe you're producing a medicine or a medication that is meant for a specific gender, and therefore the fact that it's biased is actually how you wanted this data to be, just because that's the nature of the data that you're collecting. So MindsDB cannot make those calls as to when there is bias or not, but the best thing that it can do is to warn you about them so that you can act based on that information accordingly.
Awesome. We have another question. What happens when the data changes during training?
Yeah, that's again, all of these are great questions. So being able to do machine learning at data layer allows you to treat machine learning models similar how you treat data. So if your data is changing as you're adding more rows, that not necessarily mean that your data distribution is changing. And one of the things that you can do on the syntax that we have for you to create a model is to define a frequency into which you want to train this model. And that allows you to then have your own heuristics as to how often do you think your model needs to be retrained. Now, the second thing is, if the actual schema of the data changes, then you can follow the same practices that you do with migrations on data. So any table that depends on a table that is changing, then the same thing applies to models that depend on that, on those tables. So all that you need to do is to retrain the model when that happens, and then MindsDB figures out the changes on the actual schema. And therefore, you're thinking of these changes the same way that you're thinking of changes in data, and you're managing them the same way that you do with data changes in your database. So keeping everything at that layer, or at the data layer stack, allows you to think of those problems not as two separate problems that you have to deal with in tandem, but more as one single problem that you're managing the same way. Data migrations is the best path for you, and that applies to MindsDB and machine learning models in the database.
Awesome. Another question, can I deploy a pre-built model?
Yeah, So the question has two answers. One is, if you're going for the newest version of MindsDB Cloud, we now are enabling you to bring your own models. It's a simple process. You just have to wrap your model in a class that has two methods, train and predict, and then you can upload them. For the cloud, we are still having this feature constrained to like certain users. But if that's what you want to do with MindsDB Cloud, please again reach out to us on community, and we will define what will be the best way for you to do that. But that is to say, the roadmap, of course, for us is to ensure that this capability is enabled both for on-premise users as well as to cloud users, and that we will support as much flexibility in that case.
Next question is this available in SingleStore managed service?
Yeah, absolutely. So as Jorge showed, MindsDB now has their cloud platform, and the two cloud platforms can connect directly together to work really, really well. We also both support an on-premise deployment if needed, or a sort of like in your own cloud style deployment. So no matter how you deploy MindsDB in SingleStore, we can work together.
Next question here is, what is the data lake SingleStore supports?
That's a great question. So we currently support for general for general usage, so like being able to read data out of data lakes, being able to read streams out of data lakes, move data back and forth to data lakes. We support all of the big three data lakes. The ones that I consider the big three, this is my opinion, is Google Storage, Azure Storage, or Azure Data Lake Gen 2, and AWS S3. The new feature that we just announced in 7.5, universal storage with sort of what we are calling like unlimited storage, so the ability to sort of tier data up and down into data lakes, is currently fully supported like in production on AWS S3, and all new 7.5 clusters on cloud will be, on the SingleStore managed service will be able to leverage that. We will be pushing for Azure and Google support as soon as possible. So we're looking for basically this calendar year, we'll be able to support all three clouds for unlimited storage, but that doesn't stop you from deploying on all three cloud platforms and using SingleStore.
We have one last question. Does MindsDB ML data enrichment persist in SingleStore?
No. So MindsDB makes the predictions on the fly. As soon as you run the query, then MindsDB will run whatever data you're joining it with, or whatever you have in the where statement as input to the model, and then you get those results. We are working on deeper integration with SingleStore of external tables, and that will allow you to bring those tables directly into SingleStore, or even those views of joining models with other tables, and then you can rely on the persisting capabilities of kind of like materialized views and whatnot that the database provides for you. So that's the path that we see if you want to persist data or cache that data. We also have on our roadmap the implementation of materialized views too, if you want to go directly into MindsDB for that. But for now, MindsDB runs those predictions on demand, and then again, nothing's persisted.
I was just going to say to that point, I mean, I'm super excited to work with MindsDB on some of these deeper integrations, and just have sort of dreams and visions of, even fancier integrations like computed columns on a table running a MindsDB model. So imagine you have a users table, storing key attributes about your users, and then literally have just a materialized predicted result column that is continually being updated in the background by SingleStore and MindsDB, right? Like, how cool is that? And imagine when your app dev goes, oh, how do I get access to this model? And you say, well, you already have access. Just add this column to your projection and you're good to go. That's the future that I think I really want to see, and I think Jorge would agree with me that that's sort of a really cool future.
Yeah, totally. I think that the more you guys are involved in this community, the more we can build those features tailored to your needs. But the ideas that we have are essentially to make it as seamless as possible for all of you at SingleStore.
I think we can answer one last question. We have a few minutes here. Is there any difference between the performance of SingleStore running in a Kubernetes environment compared to a bare metal deployment?
Not really. So generally in a Kubernetes world, depending on how your Kubernetes cluster is deployed is going to affect your performance a lot. Two places that you're going to see performance loss in Kubernetes deployments are going to be how you've decided to architect your network stack and how you've decided to architect your storage stack. Those are going to be the two main things. In terms of like CPU and memory access, we tend to see performance is about par with running on the same machines without the sort of container virtualization in the way. So really it comes down to how you've decided to deploy your network and your storage stack. In the case of SingleStore Managed Service, we have spent a very long time hyper optimizing our Kubernetes stack that we use for running SingleStore, and sort of do everything that we can to basically reduce that performance impact to the absolute minimum. And I don't know, Jorge, are you guys using Kubernetes in your deployments?
So we have some users deploying MindsDB with Kubernetes, and that's a process that we can help you with. But internally in MindsDB Cloud, we use a distributed system called Ray, and that relies on also containerization, but that's managed by Ray in itself.
Nice, but would have a lot of the same considerations, because in all containerized systems, you have to deal with how is your storage accesses and how are your network accesses. So yeah, I hope that answers the question.
Awesome. I want to thank everyone for the presentation today. I want to thank Oliver, Jorge, and Carl. And I want to thank everyone for attending the webinar today. We will send you a follow-up email with today's recording and a link to our managed service free trial. We are offering each user $500 in credit so you can start a full workload today. And lastly, check out our other virtual events at singlestore.com/events. Thank you for joining us and have a great rest of the day.